G'day champions, here I've got a Rivera 5512 1x12 combo. This one's got reports of sound cutting in and out, and eventually ended up with just complete loss of signal and some pretty nasty hum. So we'll crack it open and have a look. I'm pretty interested in Rivera amps in general. The genuine Riveras, not the poor Rivera design Fenders, because they were Frankensteins of amps. But it'll be interesting to play this one and get some sound samples once it's done. Now we're on the workshop bench. Like all of these amps, they just need a bit of a clean on the front panel. No serious damage. A little bit of corrosion on the input jacks there, but in reasonably good condition. The corner protectors are a bit rusty and stuff, as you'd expect of an amp this age, but you know, it's got a bit of charm to it. On some amps where the owner wanted to go the extra mile, I have taken the corner protectors off and refinished them, brushed all the rust off and neutralized it, and then prepped it and sprayed it matte black again, and that really does make it pop, as well as cleaning all the Tilex. But that's sort of like what I call the amp day spa here. It's an extra cost because obviously there's more time involved there. So a quick look at the front. You've got two inputs that are shared between two channels, switchable. You've got a boost pull pot there, bright and pull notch, and pull ninja. I forget what ninja is, I'll have to refresh my memory. Then the usual reverb and presence on the master. When you're not using the foot switch, you just pull that pot to select between the two channels. You've got your IEC input there. You've got two user accessible fuses, the mains fuse and the HT fuse. I wonder if those stickers are from the factory or if someone's actually modified this for 250 volts, it says. 240, 250. You've got your two speaker outlets there and a line out, and it even shows you the line impedance there, which is cool. Foot switch, it's got a DIN connector there. So they've gone with an 8-pin DIN connector there for the foot switch. They can be a little bit delicate, easy to damage those connectors. You can get some like Canon or XLR style multi-pin connectors that would have been a bit more durable, but they cost quite a bit more. You got the effects loop with adjustable return level and send level, and it shows you the impedances there as well. Now it's nice to see they've used machine screws and threaded inserts. That's what I do on all my cabinets if I can. A little bit better for durability and serviceability. You're not reaming out the timber a little bit each time that you remove and reinstall stuff. Alright, well we've got what may be the original EL34s in there. They're actually branded Rivera, and the speaker terminals look like they were probably factory as well. So there's every possibility this has never been taken apart before, so that's always a good sign, because as we know on this channel, the biggest threat to any amplifier is other technicians. We've got our Tektronix reverb tank down there, a little shorty. Needs a little bit of a clean up down there, and the cables, I might remove those cables and actually give them a clean the connectors, that kind of thing, just to make sure everything's sweet. Even the speaker's got Rivera branding on it, G12T85. A quick look inside at the guts. No obvious burns or anything. No blown fuses. Nothing looks really overheated. So everything on this looks kind of crowded, but it's pretty well thought out. They've tried to keep the traces as short as possible. There's quite a bit going on. It's not a very simple amp. It's quite complex in the scheme of things, but see, they've got the component designators next to the part, not under the friggin' part like Mesa Boogie do. They've even got like test points shown, the voltage given that you should be reading. Just like really well thought out, and obviously thinking about service when they were designing it, because just marking things like bias there, like there's no reason to write that unless you're trying to help out the next guy that works on it. So that's kind of cool. There's a lot of flux smattered around. It looks like they didn't go to any effort to clean flux off the board after construction. It's quite possible these were hand soldered too. Normally if it was wave soldered, you'd have almost no solder on the top of the board and no flux either. So these were probably hand assembled and hand soldered by actual humans. Can you believe it? Got the reefer madness down there. That cap's already starting to crack. What happens is the casing on these, the reefer and the what's the other brand? Reefer, and I remember reefer because smoke comes out of them. I can't remember the other brand, but yeah, there's two that look very similar, and the outside casing cracks, like the plastic degrades, and then moisture finds its way in and the things catch fire. Quite often you'll get bits of hi-fi gear, test equipment, and guitar amps, and really dramatic smokes come out of the thing and it stinks, and all you find is just one of them spontaneously shorted, and then you can just replace that and move on. And any fuses and any schmoo on the board that it's left behind cleans up reasonably easily with alcohol. So we've got Nichicon 105 degree rated radials there. It's good having radials. The only issue with that is you've got to design the amp so you can remove the board relatively easily, because obviously you can't get to those solder joints to replace them without removing the board. But when you've got caps of this quality, you don't need to remove them for multiple decades. They'll be fine, unless, you know, something drastic happens, like they cop a spike or whatever. But yeah, the Nichicon's sort of my preferred brand. All the cons, Nippon, Chemicon, Nichicon, Jamicon, they're all good. And we've got some actual linear regulators over there with pretty chunky heat sinks, really. So they must be running them up to pretty close to their rated current. Let's see how much we can glean from this without a schematic. And then if anything needs clarification, or I just want to demonstrate anything, we'll pull up the schematic and have a look at it then. So just a quick look at the secondaries of the power transformer here. We've got 2 orange windings, we've got 3 reds, 3 greys, and 2 greens. So what does that tell us? The 2 greens, the chunky ones, they're likely to be heaters, and yes, they disappear off to the output board. The 2 orange, we can tell by this capacitor down here, which is 100 microfarad, 100 volt, that's likely the bias supply. And the grey windings here, and we've got a bridge rectifier, and then we've got 2 35 volt caps, so that's likely a bipolar power supply. We've got fuses on both polarities. That's where our reefer cap is, and then we've got the rectifiers after that, the diodes after that, and then you've got these 2 caps here, 250 volt, 330 microfarad, so they're likely in series, and you've got 2 more likely in series here, and your typical 2 balancing resistors down there to make sure that each cap sees the same voltage. It essentially creates a voltage divider with the center point at the middle point of those 2 caps, thereby equalizing the voltage on each one, making sure one doesn't go over its voltage rating. You can see here it's likely a high voltage dropper. Then you got another 22 microfarad 450, and down here we've got some local filtering, 10 and 10 microfarad 450 volt, and over at the front end we've got one more, a 10 microfarad 450 volt. So without looking at the schematic, we can tell we've got 1 voltage rail here, which is a high tension. We've got 2 rails somewhere here. We've got 1 regulator here, which is a positive 18 volt. Then we've got 2 more up the other end. And there's another little filter down here, probably for the bias, which is 10 microfarad on 160 volt rated. So we've got a couple of op amps in this thing, which is why we've got the bipolar supply. We've got 2 transistors here, tip 30D, tip 29B, so they're a complementary pair, likely driving the reverb, because there's no reverb transformer on this unit. Now we've got a choke. You can see it comes from the B plus here. You got your HT fuse, that's the secondary, the output of the HT fuse. That's coming from your standby switch, that's the input of the HT fuse. So that goes off to the B plus, which literally goes straight down into the output transformer center tap. And then the black wire here, which is the choke. It actually says choke on the board there, because these boards are very nice and they tell you exactly what's going on. And the return wire comes over here. Then you've got your 2 screen grid resistors, which are 1K 5 watt, and then that goes to your pin 4 on each socket, which is your screen grid pin. So from that point it comes back to the main board here. Can't see where the trace is going on the bottom, but you can see here that's connected to ground. So this is likely this filter stage here. And we can easily measure that. Just check for continuity. Yes, we're connected. So that there is the screen node. And then this drops to the phase inverter node. So that there, all of this is connected. So that's your screen grid node there, connected to your filter stages here, those 2 series caps. And that's connected also to the input of this dropper resistor, and then that goes off to your first, well, not preamp node, but phase inverter node. You got another dropper here. You can see the trace is connected, those two. So that could be considered your first preamp node. And following the trace down here, you can see R134. That's plate load for V4B. Just check continuity there. Yep. And then there's another plate load. We can check them. This is all just passive tests you can do without a schematic. This is just showing you how to sort of suss out the architecture of an amp that looks a little bit intimidating on first glance. So this is the phase inverter here, V5, likely long tail pair. The output of this dropper should have continuity, and it does, to that plate load, which is 100K. Let's just check that it actually is. Yeah, 100, and these two are likely connected. Yep. So there's your V5A plate load, showing 82K, and it is 82.1K. So straight away, looking at the silk screen, you can see on pins 4 and 5, it's got some DC voltage measurements written in the silk screen. 18 volts DC on pin 5. Also over here on V1, 8 plus 18 volts. This is minus 18 volts. So it looks like they're running all the heaters on a sort of like a series string on DC voltage, and 18 volts makes me think that that might be regulated, because we've got 2 18 volt regulators over here. One that's a 78 18, which is a positive 18 volts, and this one's a 79 18, which is negative. So I think they're hanging all of these heaters off a regulated plus minus 18 volt bipolar supply. You don't really need to regulate heaters. It would have been better to run them all on a string pre-regulator, because that's a lot of current for the regulator to handle, somewhat unnecessarily. So that's suspicious. Alright, so I'm going to feed it some mains power now. We're going to slowly ramp it up and just make sure there's no shorts, and once we've established that, we'll start taking some measurements. Alright, so we've got everything set about midway. We've given it power, we've checked the fuse ratings are correct, and I've checked it on the variac to make sure there's no you know, runaway power draw or anything that would indicate a short. Take it out of standby. She's going up to about 80 watts and settling there, which is about right, and no signal on either channel. So let's just check in the effects return what we get. So, and the signal doesn't sound quite right. It sounds a little bit low level and distorted. So let's just check some voltages. You can see the meter here, that's just DC volts. Pin 1, V1, 367, that seems high. So straight away, pin 3, that's the cathode, 0 volts. So that triode's not conducting. V1B, got 367, again that seems high, and its cathode has nothing on it, so that's not conducting either. So that indicates usually a heater fault, or no valve installed. In this case we know the valve's there. We've got 2.6 volts where the silk screen's telling us we should have plus 18, and on 5 we've got 0.6. Now pin 9, which is halfway between those, is about half that voltage differential. So these are the two triodes, the heaters are wired in series, and there's precisely fuck all of a voltage drop across them. That's why we're not getting any conduction there. So let's move on to the next one, have a look at its heaters. Minus 6.2, 0.7. So pin 1, 360, pin 3, so that's not conducting either. Pin 9 should be at ground. There is a slight high frequency, sounds like around 3 or maybe 4 or 5K tone coming from the power transformer, but I'll show you that in a sec. So I'm sus on these regulated heaters. So let's have a look at those regulators down there. So I love this little amp. Look, it even tells you the input and the output pin of the regulator and the ground on the silk screen. You just don't get that kind of service anywhere else. So let's check the voltage. You have to be very careful not to short things out or the pins to each other. So I keep my pinky on the edge of the chassis just to steady the hand. So on the output, we're getting 7.2 volts. So let's just check that we've got enough input. We're getting 24 volts input, so that should be enough of the dropout. So the dropout voltage of a regulator is the margin of voltage that it needs on the input in order to regulate the output properly. So for example, off the top of my head, say an 18 volt regulator has a 3 volt dropout, so you've got to give it at least 21 volts for it to regulate 18 volts properly. You can get low dropout regulators that have a very small dropout voltage. But these are just your regular 7818s. I'd have to have a look at the data sheet to know what the actual dropout is, but 24 volts should be adequate. Now let's look at the negative regulator. The pins are a different order. Instead of in, ground, out, it goes out, in, ground. So I'll have a look at the closest pin to us. That should be the output. And that's giving minus 18.6 volts. And the input's 24 volts. Okay, so I removed the regulator without too many problems, but what happened was I had to apply quite a bit of solder to there to melt all 3 pads at once, and as soon as I removed the chip, that disappeared down through the hole. So now we'll have little stalactites of solder hanging from the bottom, possibly shorting out on things or on each other. So I didn't want to, but we're gonna have to remove the board. But you know what, that gives us an opportunity to just inspect it and just make sure there's no other issues down there as well. Always a little bit nervous working on an amp that I haven't actually inspected the bottom of the board thoroughly. So for a bit of peace of mind, we'll pull it out, we'll have a look. I've removed the knobs, just removed the hardware, a couple of screws, removed the valves, the valve shields, blah blah blah. All the wires on this one. This is kind of how I'd probably design a amp if I were, you know, a millionaire. Have all the pots on one side, preamp valves mounted on the circuit board, not a lot of heat there, not a huge voltage differential, and I would personally mount the output valves just on the chassis, but they've chosen a separate board there. But point being, I would make all the wires connected like a common point and make the whole thing be able to sort of hinge up without having to unsolder anything. Take note, Mesa Boogie, that would be nice if you did that in the future, just saying. You can see here that sometimes the factory likes to remount screws too. That red paint is unbroken, but that screw is pretty damaged. Alright, that wasn't a lot of fun. I can think of better things to do with my spare time, but at least now we can have an inspection and set our mind at ease that the bottom of the board's in good condition. And there's the mess I made. You can see the 3 pins there from the regulator, 2 of which are bridged. So that often happens on Fender eyelet boards. People work on them over and over again, removing, reinstalling bits and pieces, mods and whatever. And yeah, the solder connection looks fine from above, but when you look between the eyelet board and the insulating board, there's a big pancake of solder sandwiched between the two. And all it takes is that to become loose and roll around and short other things out, and you've got some dramas on your hands.